Hey guys, what's up and welcome to the Phil Studio. Today is a great day because this is the last part of the homemade PCB. So today we're going to populate the board and do some clean soldering job on the PCB. I'll mention again, this is a dual polarity variable power supply using the LM317 and 337. The all were drilled and it's pretty clean except for one part. I think I messed up here. Here you can see the hole are pretty big. I think I messed up with the LM317 drawing, but this should not be a problem as long as the adjust and the input pin are not shorted to the output pin. So we're going to solder all of the parts. Enjoy. We have all the little part here in this nice red box. We're going to start with the input terminal connector, 3-pin. And take in consideration that this is the copper. This is where you will do your solder point. So you have to know that everything is inverted, right? So let's put this here. It fits nice and tight. I'm going to show you how to do a nice solder. So your soldering iron is hot, 750 Fahrenheit. What I do is I clean my tip. I add a little bit of solder on the tip. I let it rest on the copper pad and make sure it touches the pin I want to solder. Add a little bit more solder and it should solder by itself. Like when you add the lead, it should just melt by itself. Just like that. Make sure you have a clean solder, like it's round and clean. Let's focus on that. So do the same for all the other pin, and this should rest in place. Nice. So it's done for the first connector here. And then we have these big capacitor, 4700 microfarad. For the temperature, I think I said 7500, but it's 7.500, like 750 Fahrenheit for the temp of the soldering iron. So make sure the polarity is right, like the plus is here, so it should be that way, but when you turn it, like the plus is gonna be there, so make sure the polarity is right. And on the negative part, you will have to solder the plus to the zero, well, the ground, and the negative leg of the capacitor to the most negative voltage of your circuit, which is like the real negative. This is the zero, the center is the zero. All of this is the ground in the center. So it's 0 volt minus voltage, which in our case is going to be adjustable from 3 to something like 30 volt, I think. So we're going to solder these nice big capacitor. Make sure they are flattened on the surface of your PCB. What you can do is solder one leg first, and while it's still hot, you just push it so it gets flat on the PCB like that. That's a nice job. So these caps are pretty big, and I'm scared they're gonna move, so maybe I'm gonna add a little tiny amount of silicone or, well, hot glue. If you want, it's quick to use. It's not bad. Just to make sure like doesn't move too much and end up like in a bad solder joint or a cold solder. One leg first. Push the cap. Make sure it's flat. Good. Now we can solder the other leg. Since this part is pretty big, I'm adding more solder than usual to make sure like you have a nice amount around the leg as well as on the leg. So that seems pretty good. So what we're gonna do now is cut the excess of the leg. Flush cutter. Don't cut too close to the solder, you will just damage the solder job you did. Okay, so this is good for this here. Make sure you have your schematic closed, because now we need to put a 0.1 microfarad capacitor. They are pretty small, and these are filtering capacitor. So like be really quick with this one, because if you hold it with your hand, it can get pretty hot. So once you have one leg soldered, make sure it's well aligned, flat on the board, on the PC board, the PCB, PC board, yeah. And then you solder the other leg. These capacitors are not polarity sensitive. There's no polarity on these kind of cap. So you can see we have a little hole here because the gap is too big. So you fit it nicely. There, you have a nice job. Make sure they don't become too hot. Don't want to damage them. So don't eat it for too long. Do the same on the other side of the board here. So one leg first, just so it stick to the copper. Get really hot, be careful. Like if you want to use your third end, like that's perfectly fine. That's recommended even. So one leg is soldered. Make sure it cools down before you solder the other leg. Oh, we messed up here. Okay. So that's a clean job too. Looks good. We have both of our big cap, small cap here. And then comes the tricky part. We're there to the LM317 on the positive side and the 37 on the negative side. So make sure you put the right one on the right spot. This seems like the 337 negative and the 317. So these parts are like, they look like they are the same, but they do not have the same pinout. So make sure you don't mess this up. As the 317, the casing and everything under is the output. There is a little offset with the pin. If I place it that way, the in is up, the adjust is down, and the output is all connected to this copper plate, which goes to some more component and to the output here. So you place it down here. I'm gonna have, for this, I think I'm gonna use a tiny amount of thermal compound, and I will need to create a copper trace here and use two screw to screw like this part in place and make sure it doesn't move. So I'm going to use two screw. So I will have to drill some bigger hole for this. I hope I don't break my PCB and the copper. Make sure you wear gloves. Make sure you wear your protection glasses when drilling. And like double check your stuff before drilling. This hole here. So I think it's a bit big, but battery's dead. Always ready for that. And I'm going to use this here to drill. It's gonna help. So we have like a really big hole, I think. But still, the screw is gonna be able to make the connection with the copper and the part. Be really careful. That's it. My guess is that I should create the copper trace before soldering and placing this part in place. So like I mentioned in the first video, I'm going to use this nice copper foil tape from the fruit. I'm not sure if it's gonna be the best for that kind of job. I hope so. I think I'm gonna have to do a little angle here because I don't want to short the screw with the copper trace. So I'm gonna do a little that and that, a little curve. Cut the desired length with some scissor. It's really easy to use. It's like it's really a nice product for real. I just discovered that like this year and just rock. It's rock. So it's thick on the surface. And I think we're gonna need to create a via to go from this trace to the other part here. I think I know what I'm gonna use. Like I don't know if it's the best thing, but it's gonna provide me with a test point as well. So I think it's good. It's pretty nice. Can just pierce it down into the hole. So it's really easy to stick. Now I have a via, but I want solder on the top and the bottom. So I'll have to hold it like that for a while. And make sure there is solder on both trace. I know this is not gonna be something easy, but we're going to try anyway. So solder back side of the PCB. Don't touch this, it's gonna get really hot. So what you can do is take your little plier or cutter and align it straight like that. So you can see the sticky surface was just coming off. I'm going to glue it back, make sure it holds in place, and then the tricky part, I'm going to solder the top. Don't want to melt the plastic either. That's easy. Yep, I think this is gonna work really well. I don't really like this pin because if you touch it, like it directly on the power, but this is something I could work like in the future. I don't know. Well, anyway, this board is gonna be housed into a safe case, so no one should ever get to put his little tiny finger. Another trace here. Okay, so both sides are conductive, even the side with the glue, but to be safer, I'm gonna create, I'm just gonna solder both part of the copper foil together to make sure they are like doing a crazy great connection. This is going to be our input pin here. And right here, the other O is the adjust pin, which is supposed to go adjust pin to a potentiometer, 4.7K potentiometer, which I have here. And I'm not going to solder the potentiometer right on the board. This would be like, I guess, really stupid. I'm going to solder 2 wires, which goes to a terminal block connector, because I want to ease the process of plugging, unplugging, or just, I don't know if I need to remove the board, do some troubleshooting. It's really nice to be able to remove the board without having to unscrew the potentiometer from the casing. I'm not going to solder this right away. I'm gonna work like really well on that one here and make it perfect. My biggest concern here was the short between like this plate here, which is the output, and the input or the adjust. I don't want any connection between this path here and this big trace here. So how am I gonna do that? Well, for now, I'm just gonna solder everything, and after that, I'm going to measure with my multimeter and just make sure there is no short. So I'm going to do the trace for the adjust pin, which goes there. It's a small trace, but we still have to do it. Great. So we have a trace here. I'm gonna do the same as I did for the via. The via is a path between 2 layers of a PCB, if you're asking. And I'm using this small male header. They are single header. It's not because they are male that they are single. Okay, here we go. So I'm gonna do the same. Apply solder on this side. And then align it perfectly a little bit after. Let's go for this. This one was a bit messier than the other, but if I hit this, everything should move. Yep. Yep, I'm pretty happy with the result. I think I will have to add more solder here. This is not bad. Wow, I didn't thought of that. The copper foil is really nice, like I mentioned, but I don't know if it's the best way of doing this. Anyway, I really hope there's no short. But anyway, we're gonna check everything before plugging this. And I'm gonna test the board on my bench power supply. first. So less chance of damaging everything. Okay, so like this is some tweaking bricolage stuff, but it's going to work anyway. And now you have to make sure everything is aligned. Thermal compound, here I am. Thermal joint compound. Apply thin coat on your parts, really thin coating. And what am I gonna use as a screw? I don't want something too big, don't want something too small. This seems like it's perfect. And then, wow, that's great. That's great. I really like those tiny screws. I'm gonna take 4 with the lock nut. What is the lock nut? The lock nut is a little nut with a little lock ring, which means when you will turn, this will grab or penetrate the material and just hold in place. That's really nice when you're doing robotics. This is not robotics at all, but this is not robotic at all, but what can I say? This is not robotic at all, but I don't really care because I'm doing things like a professional. Even if the layout is a bit sketchy, like I'm trying to do stuff like a professional. So let's go. Apply a thin layer of thermal compound. This is really satisfying. Here and here. Don't need that much, huh? Like a tiny amount is perfect. Good. This copper foil is all messy, but when we're going to solder on the pin, everything is gonna stick in place and it's gonna be good. So this part is in place. The LM, I hope it's the LM317 I have in place and not the 37. Yep, it's the right one. So I'm going to place the screw on this side and the nut holder on the PCB side so it can grasp on the PCB surface. Don't screw it too tight because you want to solder. No, you want to screw before you solder. But you want to align it perfectly, so don't screw it too tight. Okay. Now, I like the way it's aligned. There's a short ear, you can see. Okay, now it's gone because you don't want the output to be shorted with this copper trace here, which is the adjust pin. This would be a real mess. So before I solder anything, I'm going to check and make sure like there's no short. Make sure it's well tight because this is probably the only way the output will be connected to the plate. It's by the compression because I won't apply any solder here or under the plate. And most of the connection is supposed to be done with the screw. So I hope I took a screw that that is conductive, and I hope it's not like shitty stainless steel. I'm going to solder these bad and verify for any short circuit. I really hope it works because this was my biggest concern here. This part of the circuit design, I I was not really ready to do a via and a 2-layer of PCB, especially with a one-sided copper PCB. So let's test this out with the multimeter, put it in the continuity checking. So this is really good. This is really good. We have continuity. No short here, between here and there. No short here, and no short. Well, this is not a short. I think we're measuring some of the transistor or the diode inside the casing. Because if I put it backward, the negative here, we'll measure a different value. So this is great. And also we're measuring the value of the capacitor charging and discharging. So that's pretty neat, guy. I'm really happy with this. No concern with this there for a spark, or because it's pretty close. Like the nut is really close to the trace, and I'm not sure I like that much. I'm gonna try to adjust a little bit of this. Just gonna verify. Okay. That looks pretty neat to me. Cut the pin carefully. All right, so this big boy here is in place. We're going to work on this one, the LM337. It's this pretty much the same thing. Make sure there's no short between. Yeah, that's pretty close, but it's all right. And here we have 2 trays to create, from the adjust to well, from the adjust pin to the potentiometer, which is the adjust trim potentiometer, and from the output, which is the leg, the uppermost leg, when you have the offset to the left. I know what I'm saying is really boring, but I'm sure you're gonna learn a load of stuff. Okay, so we're ready to drill the bigger hole for the screw. Then we're gonna create the second layer of trace from the out to the out here. Sounds good for me. Looks good. This one is gonna be tighter, and here I won't have to worry for the short between any of the leg, because I managed to get like the hole perfectly. And you see there is a ring where there is no copper, so this will ensure there is no short between the pin and the pad, like the plate. Okay, so let's create the traces. I'm gonna change my strat here. Have a longer pad and do a little curve here. It's just to give me like a safe amount of space to work. Yeah, that's great. Yep, I like that. So you can put the nut lock here. Okay. That looks pretty clean. I like that. That's cool. Cool guy. Cool guy. Okay. So we're gonna create the via. Again, I need 2. Oh, I think this one is gone. I need 2. And we're good for this, I think. So gently pierce the hole. Nice, done. So tempting to just place it with your hands, but like, don't touch that with your hands unless you really want to burn yourself. We're good for the via. Just gonna add a little bit more solder here. I hope it won't disturb the connector. No, that's fine. And here. Oh. Yeah, I guess I messed up. Nice. So, I think there shouldn't be any problem with this because this all is here for the terminal block connector. Okay, let's go. Let's give a crash course on how to unsolder a pad. Guess it's done. Pretty neat. Let's unsolder again. Eat and pump. That's what they say in the gym, right? Eat and pump. When I'm done with this, I'm gonna call you guys, okay? Okay, so this looks okay. Then what you want to do, check the continuity between both layer. So here we have a connection, but here and there, do we have a connection? Sure, why not? That's great. And here and there, well, sure. Okay, so that's there and there. Perfect. That's fine for me. Fine. Oh, I was working on that one. So let's continue with this. Okay. This is another adjust. Need to solder 1 pin. Make sure it's well in place. Watch out, don't burn yourself. It's flat, well aligned. Then you solder the other leg. Then the first leg back. That's nice. Okay, so we're good to work. We have another via here. Where did he went? Here. Okay, we're gonna go to the hole. Small hole. I really like the big caps because it's like holding the PCB for me. It's pretty convenient. Alright, and let's place it. So if you can solder with both ends, this is a nice skill to have. Okay. I think this nearly perfect. Okay. Fine to me. Perfect. So this is a bit high. This pin is a little bit high. I think he smokes too much. And I don't like this little guy here. Like, you're too long, man. You're too long. You're too high. Let's just place you a little bit. Yeah, that's good. That's okay. Let's take this cotton candy swab. Cotton swabs. I love that. Okay, so apply a thin layer. This is my favorite part. It's like painting a nice sky or a cloud with Bob Ross. Okay, some here. I think I forgot my soup in the microwave. I should go check for it. A small amount of compound. In this case, it was a generous amount of compound. The LM37 was lucky. It was spreaded with compound. Solder these two little legs. Make sure the connection is strong. Solid connection, guys. Solid. Going to check for continuity and short circuit possibility. Okay, this to there. Good. No short. No short. No short. No short. Continuity. Good. No short. No short. No short. And how about from me to you? Perfect. So like the tough part of the circuit is done. Now we have some little parts left to solder. I think I'm gonna go for a fast forward on this one. Wow. Okay, so as a real first homemade PCB, I'm really happy with the result. Like, the resistor here is a little bit high, but and as well as this pin here, but I don't think this is something that would mess the circuit. Like, I don't think it's gonna be of a big deal. And everything is identified under, which is not really useful, but I'm going to write it on like up, positive, the negative, and both output. And I have some space here in the corner to drill some hole and hold the PCB in place, because I don't want it to be too much flat aligned on the base of my casing, because it's a plastic casing. And these guys, I think they're gonna heat a little bit, so I'm gonna have some space. Maybe I'm gonna have some ventilation, like a fan, to just blow the air. I'm not sure yet. I don't think it's gonna be necessary, but as a first attempt at a PCB, I'm just really happy with the experience. Like, it was so nice to do. I want to do another and another, and there are gonna be more. So next episode we're going to like oust this into the casing and combine it with the real big power circuit here. And yeah, I've planned to include a little cheap like 5 or 10 watt amplifier in there. So I'm gonna need another board for a 12-volt regulator and a 5-volt regulator. So see you next time, guys. Really excited to continue this project.